Okay, let's try to solve the third problem. I think it's theory of machines. Okay, first let's try to read our statement. So we have a schematic of a four-cylinder engine, 4-stroke, 1-3-2-4 firing. On figure 1, I don't know why I didn't put a figure here. Okay, and then we're told that cylinder 1 fires first. Is at a TDC top, and then cylinder 3 fires 90 after, and cylinder 2 fires 180 after, and cylinder 3 fires at yes. Okay, let me just draw so that I can actually be easy for me. So this is a 4-cylinder engine. It means you have, let me say this is a engine block 1, 2, 3, 4, right? Say this is an engine block, and below here is a crankshaft. It kind of look like that, tinkly, and all these are connected to these rods, and then as this thing revolves, these guys are going up and down, right? And also it's a 4-stroke, they said, right? 4-stroke. So 4 strokes have like the limit draw maybe this thing like this. Let me say 4-stroke. First, if this guy is on top, that's where we intake. We intake and going down, we intaking. Okay, and then now when we're bottom here and we're trying to go up, then we're compressing, and then when we are there and we are going down, now that's what we call a power stroke or combustion, depending. And now we are here and we're going up. That's what we call this, exhaustion. So it's like exhaust, like it's taking out the whatever gas that was remaining here after burning, smoke, if I should say it like that. So I think the key takeaway to take here is that there are 2 times when the piston is up. It's when it's intaking and on the power stroke. So we'll see what I'm talking about actually as soon as I try to solve the problem. So primary and secondary crank. Okay, let's try to draw that. Primary takes takes 1 revolution, and then while secondary happen twice in 1 revolution. You'll see that when I'm doing the math, how that affects actually how the math works. Okay, let's try to sketching that. Okay, I don't need this guy for my problem. Let's start with primary. Okay, first of all, they told us that piston 1 is at the very top, right? Top that center, and then piston 3 fires 90 degrees after. It means we have 90 piston 3 here, and we have 90 degrees, and then piston 2 fires 180 after 3. That means 180 after 3 here. We have 2, and okay, let me read. And piston 4 fires 240 after, 270 after. That means 90, 180, then 270 is around there. That will be our 4. 270. Here we have 108. Okay, so for primary sketch, whatever value that is here, we just times it by 2. That's what it is, because remember, if this is sine, let me say, if this is sine theta, center is around here. Okay, let me say this is sine theta. show you what I'm talking about. And sine 2 theta would kind of look like so. That means in one revolution, sine theta would have happened, 2 sine theta would have happened twice, while sine theta happened once. So technically that's what secondary is. It's just happening twice in one revolution, if I should say like that. Okay, let's try to draw it here. Same thing, piston 1 is there, and then 3 is supposed to be 90, but now because it double, it will be at 180, right? And then 2 is supposed to be 180. Now it will be would be a revolution, right? It's 180 plus 180, so it will be like that and back to where it was, right? Now we have a 2 here, and then from 2 to 4 we have 270, and then if I do 270 by 2, I'm getting 540, and let me minus 1 revolution to see what am I talking about. So it will be 1 revolution and 180. That means from here to here you'll have, actually I got this thing went like that and that, and then I got it where piston 4 is, that was 540. Yeah, but let me remove all of that. So technically it says that 1 and 4 are in pairs, 1 and 3 and 2 are in pairs. Not like they fire at the same time, just that they happen to be at the top at the same time. Like, remember the part that I started with, the other one is firing, the other one is intaking, but that thing, all of them happen when it was on the top. So if this one is, let me say for first case, if one is firing, it's going down, firing, the one is going down because it is intaking. When the next one, 3 will be firing. That's what actually happening here. Then I think that answers these questions, and then calculate and tabulate the primary and okay, cool. Let's try to do that here. Let me pause and draw the whole table. Okay, this is how far I just draw the table. I'll explain other parts of the table as video go on, hopefully. All masses I made them M because these are pistons, so mass wise they should all have same mass, and R have same rod. Remember, a piston is at head, and then there's a rod that is connected to the crankshaft. So these guys are also, all of them are R, and these guys, all of them are M. So that's why I'm calling all these on MR. And then let's talk about and I think they did say something about take center of the as your reference. So if this is how do I put this? This is my shaft. This is where piston 1 is, piston 2, piston 3, 1, 2, 3, 1, 2, 3, 4. Right? And then our reference plane is there, and all of this distance I call them L's. That means if we have L, all makes sense, right? If I'm at 1, this is going to be what? 1.5 L's. We're gonna write L, but 1.5 is enough. We can write L just to make it simple. And then if I'm at 3, this is 3, we're having 0.5. If I'm at 2, we're having 0.5. You see, not enough L, but half of L. When I'm at 4, I'll have a full L and a half L. So that should be a full L and a half L. So the thetas, so the first theta will be 0. The second one is 90. For 3, for 2, where is 2? Where is 2? 2 is this one. So it will be from all the way here, it will be 90 plus 180, it will be 270. And for 4, where is 4? So I'm here at 27, right? That means I'm going all the way 180 and then a 90. That would be like 2. Remember, arriving here, it took me 270. Now I'm trying to go to it again, another 270. That means it will be around 540, right? 540. Okay, let me explain the angle thing because I think sometimes it's kind of confusing. 0, I mean 1 is at 0, 3 is at 90. You could see that on clear. I'm starting like this at 90, right? And then if I want 2, I'm already here at 90. That means I'll go 180 plus at 90. That means that'll be 270. And then now I'm at 2. I'm trying to go to 4. Remember, already took I'm here. It cost me around 270 to come here. Then to go all the way again, it will be 270. That means I'll have 270s. 270 that's what I want to say. 540. That's how I got that 540. Okay, cool. Then now we're plugging all these angles into this cos and sine, these angles that I have here. So let me just pause to make a video short. So if I didn't make any mistake, that's what it should look like. Let me test one so that I make sure. Let me test but yeah, they're obvious. Whenever sine is 0, this thing becomes 0, and yeah, makes sense. Cos that's at 0. Okay, cool. We are good to go. Is it? Let me check cos 5 just to make sure. Okay, yeah, everything is fine here. And then now I have MRL cos theta technically. Let me just cut this thing here so it kind of makes sense what I'm talking about. MRL is like whatever force. Remember, MR is a force, which I don't want to represent here because it doesn't make any difference. It can just be set by these two things. Actually, I should have put a force table. Let me just put it here. Okay, cool. It will look like this again. Okay, it will be force cos of which, let me say fx. Actually, I should have called them fx. Even these, I should call them x and y. Let me just add that table there. Fy. Well, remember, y is for sine. Cool. Let me remove this then. Okay. Now, MRL is just there like that. Should we only let me start with force. Yeah, to make it easy. So the one with I'm on cos. That just means I'm focused on this guy here. For this guy, right? So the one with zeros, which one has 0? From cos, this guy is 0. That means you'll have a 0 again. This guy is 0. That means you'll have a 0 again. So I'm interested in this guy. So this guy is going to give me a 1.5. Actually, it's a 1.5. I'm actually considering these two numbers. I'm not considering MR because MR is just to be MR everywhere. You could put it in and say 1.5 MR, which MRL. Technically, I just don't want to write it here because make my thing look dirty. Then I'm trying to move here. What am I getting here? Going throughout, it will be negative if I'm not mistaken, and that guy 1.5. So that would be a 0. Then I come here. I'll do the same thing for sine. Where is 0? The 0 will just be transposed to where I don't care. That means also here is a 0. That's why I just did that. That's why I just pushed the 0. So it'll be just me multiplying. Okay, I don't have to explain that. Okay, let's try to figure out how it works here. MR is there. L is... Oh, actually, I'm transposing wrong zeros. I'm on the sine. I should push these zeros there and there. Cool. That means I'm only doing these two. Then it means I'll have a 0.5, and then here 0.5. I think there's an error also here because let me look at where 3 is. 3 is on this side as positive. Let me look at where 2 is. 2 is on this side. That means it's negative of my response. It means 2 should get a negative thing there. Who else I need to look at? Well, 2 and 1 are negative. Let me go back here. That means this L was supposed to be negative, making this guy negative, making this guy unbalanced. Is it? Okay. So I think I fixed that. Let me move to this guy again. It's going to be a 0.5 for an L. This one will remain positive, and this guy is going to be that one, and that negative will remain positive. Okay, make this guy unbalanced, and then cool. Everywhere there are zeros, that's why I didn't write. So we can do the same thing for forces. How do we do it for forces? Same thing. Let me start on the x, where x is this guy. That means here there will be a 0, and here there will be a 0. So don't have to do that one. Then whatever that remains, when I'm here, remember I have mr and this one alone. I'm coming, I don't put an L because it's a force. L, remember, trying to MRL is a moment and MR is a force. A force here on X is going to be MR, and then cos and a -1. So this guy looks like he's trying to balance. Let me look at Y. Okay, let me do the same thing that I did, pushing the zeros. I take the 0, push it there, take that 0, push it there. That means you're only focusing on these two, right? Only focusing on these two. There are zeros where input. Okay, cool. This two, let me go here. It's going to be a 1, right? And I'm here, it's going to be a -1 if I add this. So conclusion, forces are balanced. Forces are balanced, but moment, no. Okay, cool. That answers what? I think it answers this question. Okay, I'm only going to do primary to make a video short. For secondary, you just make these angles times 2, all of them. So it'd be literally the same thing. Okay, and determine if, okay, we already did that part. And then I think the last part to do is just sketching the poly, and then that's all. We're sketching a poly of this guy, of unbalanced forces or moment. I already know from here moment is unbalanced. Let me sketch for moment. So you should use a ruler, of which I'm not going to do that for now. So what I'm going to do to plot this guy, I'll have negative is 1.5 here, so it's on the x, remember? So I'll have 1.5. It's negative this way, so this guy is negative, and also this guy is negative. And then from that, then we have a 0.5 on y, two 0.5s that are, there's first a 0.5 that are positive, and there's another 0.5. Then from then we'll have another negative x, that's why I'm getting this. Then negative x of 1.5, right? And that means our resultant will be looking like that, with some angle here. How do you find this angle? You can actually use math. You'll have a and b, you're trying to find r. You can use Pythagoras, and from then you can find the angle. And then if I compute, I normally use this this method of using complex method on your calculator, which is way easier. But for now, let's just say the answer is, okay, let me go. And if you use this method, it's going to give you this angle. Remember, you want an angle like that, so you have to subtract 180 to it. So yeah, so for primary, for secondary, you're just going to take this angle. Is going to be 0, 180, 540 onwards, and then you do almost everything the same as I did. Thank you.